quick summary of the preceding. Rational function y equals x plus 7 quantity squared over x plus 5, the reciprocal of the function we did before. Numerator now has degree 2, denominator has degree 1. This is a rational function then, and it has an oblique asymptote since the numerator, the degree of the numerator is 1 greater than that of the denominator. Okay, now numerator equals 0 when? Well, obviously when x equals negative 7. Denominator 0 when? Well, obviously if x equals negative 5. This implies that we have a 0 at negative 7, 0. X equals negative 7, y equals 0. And we have a vertical asymptote at x equals negative 5 because the denominator is 0 at that point and the numerator is not. The numerator would be 4 at x equals negative 5. So as x approaches negative 5, the denominator approaches 0, the numerator stays around x equals around 4. So we're dividing 4 by numbers that get closer and closer to 0, giving us larger and larger positive or negative results, as we'll see in a few minutes. The y-intercept, plug in x equals 0, we have 7 squared over 5, which is 49 over 5. Okay, our oblique asymptote. How do you get the oblique asymptote? You got to do a long division. We divide x plus 5 into x squared plus 14x plus 49. X goes into x squared, x times x multiplied by x plus 5 is x squared plus 5x. Subtracting, we get 9x, bring down the 49. X goes into 9x, 9 times x plus 5 is 9x plus 45. Subtracting, we get a remainder of 4, meaning that the result is x plus 9 plus the remainder over the divisor, 4 over x plus 5. So that y equals x plus 7 quantity squared over x plus 5 is equal to x plus 9 plus 4 over x plus 5. As x gets very large, whether positive or negative, this denominator gets very large, making the fraction 4 over x plus 5 very small, so that the value of y is going to be close to the value of x plus 9, giving us an oblique asymptote y equals x plus 9. Putting all this information on the graph, we plot our vertical intercept, we plot our vertical asymptote, we plot our 0 of the function, okay, on the x-axis. We sketch the line y equals x plus 9, noting that the y scale is somewhat more compressed than the x scale, so this doesn't really look like it has a slope of 1, but it does. Knowing that to the right of x equals negative 5, the denominator is positive, and that the numerator is always positive, being a square, the function has to remain positive all the way to the right of here. Since it's positive here, that means it's got to be positive here. Okay, it's got to come down from a positive asymptote. It's got to approach infinity in the positive direction. It might come down through this line and then back up over like the white line and eventually approach the intercept, or it might take a more direct approach like this red line coming through the intercept again and becoming asymptotic to y equals x plus 4. A little more compact picture of the graph allows us to see what happens on the negative side of the x equals negative 5 line. The vertical asymptote will approach the x equals negative 5 line through negative values, because to the left of x equals negative 5, the denominator is always negative, the numerator stays positive, being a square. We have to go through this 0 at negative 7, 0. How do we do that? Well, this 0 comes from a squared function, meaning that in the neighborhood of that 0, the graph is going to be kind of a parabolic. So it might look something like this. It's going to just touch this point. It's not going to go through the x-axis, just going to kiss the x-axis at this point, much like the vertex of a parabola, and then it's going to go off and approach the negative, or the oblique asymptote y equals x plus 9.